All right, welcome in. So as promised and long overdue, project 2, right, for 264, Flowing Fountain Forge. Now, as usual, please go through and actually read the directions, right? You'll notice part 1 gives you some additional operations. The very first one talks about a vector function or vector valued function. If you scroll down to the first part that we're going to be doing, this is exactly what we will need. Right now, obviously, this f and this g are going to be slightly different. However, right, it'll be kind of the same structure. So we'll go down to part 1, and then we'll jump over to MATLAB here. Okay, so let's see. Scroll. Part 1 exercises. Open a new script. Type in your name. Type in your student ID. Nothing different here, right? Always the same thing. So we'll do that in a second. For the remainder of this project, A is equal to your last digit, B is the second to last, C, etc., D is the sum. Right, so same as all the other projects in 264 and 262. We'll get to 1B in a second. Let's take care of the easy stuff and go into it. So MATLAB, I saved it as Flowing Fountain Forge, or FF, by last name Ragsdale. Remember, % for comments, my name, and I'll just do student ID. Obviously, it'll be different. And we want to save some variables, and we're going to label this. So help me out grading wise so I know exactly what I'm looking at. We'll call this 1A, in which we have A is equal to our last digit, 7. I put a semicolon if I don't want it to output to the command window. B is equal to 6. C is equal to 5. And we can say D is equal to A plus B plus C. Again, semicolons are only needed if you don't want it to output to the command window. I don't like to see everything output to the command window. It makes it a little bit messy, let's say. So we'll leave this, Control Save. And again, if you're taking any computer science classes, the code has to run, right? So even though it seems dumb that we only have this, make sure it runs, right? It's very easy to have some syntax errors. I can see in my workspace here, 7, 6, 5, 18, right? So all of that stuff is saved. Now we can move on to 1B. And for these parts, I'm only going to get you started. I'm not going to do the whole thing, but it should hopefully be helpful. Okay, so 1B, consider the vector function. So as I mentioned, the additional operations are above, right, given below. Define this MATLAB, then find its one-sided limits and its two-sided limits at t is equal to pi, its derivative with respect to t, and antiderivative with respect to t. Call these results in order: P1B left, P1B right, P1B2, derivative, and antiderivative. Okay? Right, so we could scroll up and we could probably see the operations, and I'll do so quickly. So let's see. Keep scrolling. Right, we need to define our parameters, sims. We have some limits here, so again, it's going to give us, it'll help us here, right? Limit of f tells you the variable, outputs the limit at t is equal to 0, so our t is going to be pi, right? So here are the operations that we need. I'm going to drag this back over. Let's go ahead, we'll open up MATLAB again, and we will open up this on my side. Okay, so part 1B. I'm going to do some of this for us. First thing we need to do is define the symbolic variable t. And now we need to go define our function, right? So we had a function there. Let me open it up on my side. I believe it was called v. Yep, so we have v is equal to, and then a vector, right? Vector valued function. So let's go ahead and type that in. So we have v is equal to, now to input a vector, we need brackets. Don't try to put the angles, right? And now we have a plus 1 times square root of t cubed. And we're going to put a semicolon, right? So that is our first component of our vector. And then we have bracket, b plus 1, jump outside one of the brackets, times sine of t minus pi, and it should read pi as such. We'll jump out of the first bracket, we'll jump out of the second bracket, and now we need to divide it by, and we'll go match this up to make sure it's all right. Two brackets again, c plus 1 times t minus pi. This needs to be in brackets as well. Bracket, bracket. And we have a third component here. It is t minus d. And again, we've already defined a, b, and c. If you have not done so, please do so. Don't be skipping parts, or else it's not going to know what to do with b, d, c, etc. We'll control save it. And again, once you write a piece of code, let's make sure it runs. So before we even do any of the limits, let's go ahead and run it. It does say v is a 3 by 1. We do have t as a symbolic variable. We are good. So 3 rows by 1 column, right? So this is known as a column vector, you could think of. 3 rows, yes, 3 rows, 1 column. Okay, so we want to go call P1B left. P1B left. I'm only going to do left. You'll be responsible for right, but it is a very easy switch, right? So P1B left is going to be equal to the limit, which is a command that we just learned from our additional operations. And we need to feed it some arguments. We're going to feed it v for the actual function. We're going to feed it t to know what variable to deal with. And we're going to go with pi as where we want to evaluate this limit at. And we need to feed it the extra argument of left, right? That tells us this will be a left-hand function. Now, I don't think it matters if it's 1 quote or 2 quote. I'm going to go with 1. That's fine. And again, semicolon. Now, if you want this to output to the command window, that's fine. I guess let's go ahead and see. I'll command save. We'll run it. So we have an actual answer here. Now, again, we have 3 different components, right? We have 3 different parts here because we have 3 components of our vector, so it makes sense that we have 3 different parts. We can see P1B left, again, is a 3 by 1. I don't want it to output to the command window, so I'm just going to put a semicolon. It does help to do that before, so you can check. So again, in comments, you guys need to go do P1B right, which is very similar, right, as far as syntax. And this is equal to something, 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 right? Same idea. And this is P1B two-sided limit, right, is equal to something, something, something. So feel free to pause the video and complete the rest of those. Okay, hopefully you paused the video. I'm going to do the derivative, which is P1B derivative, and this is equal to diff, right, saying I'm taking the derivative of v with respect to t, and semicolon. Let's go ahead, we'll output it to command window first to see if it runs. And it does indeed run, P1B derivative, right, again, should be a 3 by 1. Now you guys are responsible for going to find P1B anti. And there is an additional operation. Again, go back to your instructions here. Very simple syntax, etc. Okay, so now what we're going to do, I'm debating. Should I go in and fill this for you? No, we'll leave it. So now what you're going to do is you're going to take this same idea, except we're going to extend it into multivariable functions, right? That was just one function of, or one variable of t, there we go. And now we're going to be dealing with multivariable functions, so we'll do 1c. And I might make 2 videos or else these will be a little bit long. So we'll do this first one, 1c. Let's go back. Let me drag this back over. Let's see. There we go. 1c, so we did 1a. We did 1b. Right, again, feel free to pause. Right, so this is for 1b. Consider the multivariable function given below. Define this in MATLAB, then complete the following task. Compute all of its first partial derivatives. Partial with respect to x, partial with respect to y. Calculate its gradient. Call it P1CG. Right, well, if we have both of these, we have the gradient. Find the directional derivative in the direction of n, which is already specified at the point 1, 1. Call it P1CDD, determine the tangent plane at 1, 1, call it P1CTP, and plot the tangent plane together with f on the same set of axes, figure 1. Right, so there's quite a bit going on here. I'll walk us through the process. I'll leave some of this for you guys to do, and we will go ahead and jump through it. Looks like 1D is going to be similar, so maybe I'll leave that one for you guys. But at least we'll get through 1C. Let's go ahead and get started on 1C. So very first thing, again, if you're looking at your instruction sheets, we're going to be taking the partials with respect to x and y, so we need to define some symbolic variables. We'll say sims x and y, right? And now we'll define that function. We'll just call it f. This is a multivariable function. Let me move this out of the way over here. It's in the way. Multivariable function, not a vector valued function. So we'll just say parentheses, parentheses, a plus 1. And this is times, we have x minus c squared. Good. And now we're going to jump outside. We're going to minus parentheses, parentheses, b plus 1 times y minus a. And is this also squared? This is also squared. And we're going to put a semicolon so it doesn't output it to the command window. But again, check your syntax immediately. So I run CLC to clear this out. We can push run. Oh, and we did not output anything, so that's fine, right? We did make sure that f does indeed run. We don't have any syntax errors. We're ready to move on. Okay, so go back, look through the additional operations. If we want to get P1CX, right, so I'm just going to write down, let's say, partial derivatives, just so I know, right? And I have P1CX, and this is going to be equal to, we're going to still use the diff command for differentiating. We take it of f with respect to x, and that is all there is to it. Now I'm going to control save it, and we'll see it output to the command window. Boom. So we have it output to the command window. That is awesome. I'm going to put a semicolon so it no longer does that. I think we can be responsible for computing P1CY, right? There shouldn't be a huge jump in logic on how to put that in. So feel free to pause. And I also will do this one for us. So P1CG, which is the gradient, there actually is a command. Again, if you go into your instructions, everything is given to you guys there. We won't ever try to trick you. I need to feed it a function, and I need to feed it with what I am taking the derivative with respect to in which order for the components. And again, control save, run. And again, you can see that my P1CX is here, and you should also get an idea of what your P1CY should be. I'll just put this here so we know, right? Even though it's clearly in the command, I'm going to put a semicolon. I'll control save. And what else do we have to do here? Now, okay, so if I want to create a directional derivative, right, in the direction of n, which is specified in the instructions, I need to make sure n is what? Well, first of all, I need to make sure n is a variable that I have, right? So n is equal to the derivative, or not the derivative, n is equal to the vector, which we're specifying is d minus 5 and d minus 15. Control save, or maybe we'll do this real quick. We'll make sure it outputs, you know, and then we can run it. So you can see how many times I run this. Please, if you take a computer science program, this is always a good idea. Write some code, make sure it runs. Especially, I know MATLAB's very nice, it'll tell you where the mistake is. But if you're using other text editors, it's not going to be so nice. You just have to go figure it out yourself. So let's specify. We specified what n is. What do we need to make sure n is? We need to make sure it is a unit vector, correct? So let's go ahead. We're going to specify, let's say, make unit vector. We specified what n was, and now we're going to call u, which is going to be equal to n, but we need to divide it by the norm, which is the magnitude, right, of n. And we can see what u is. Let's go ahead and control save. Again, output to the command window. And we get some ugly numbers, but that's fine. Okay, so our next thing that we want to do here, if we want the directional derivative, and again, we're just writing some commands to ourselves. Directional derivative, what do we need to do? Well, we need to take the gradient, so we call this one P1C. I believe we call this directional derivative, dd, is equal to the gradient, but I think we need to apply it, right? It's equal to, yes, the dot product. So let's do the dot product between u, right, which is what we just specified, and P1CG. Control save, and let's do control save and run and see what we get. Awesome. All right, let's go back to the instructions. I feel like maybe we should have substituted in, or are we supposed to do it in the next part? Let's see. So we have calculate the gradient, find the directional derivative in the direction of n at the point 1, 1. So we are supposed to apply the point 1, 1. So let's see if we can actually do that. So we need to, oh wait. Call it, yeah, so we want to do that first. So let's go back in. We want to apply the point 1, 1 here into x and y. So we need another subs command. Let's see. Yeah, so maybe we're going to do this instead. P1CG, okay, 1 second. So if we have our gradient, can we do subs into, or do we need to do it each one individually first? Okay, so what we're going to do, we need to do one more part here. So we're actually going to call this a temporary variable. We'll just put temp here to save its place, because we want to apply the point 1, 1. So we're going to say P1C dd is equal to, and then we'll call the subs command, say subs. We'll then call our P1CCD temp. We need to take x and y and replace them with 1, 1, right? And that's just purely from the instructions, right? These aren't just numbers I've made up. This is from the instructions. We want to calculate what the directional derivative is at 1, 1. So we're going to go substitute 1, 1 in there, and we can control save. It'll be a very ugly number here, right? And that's fine. So I'll go through all the way through 1C. I feel like that's fair, and then I'll leave you guys with D, and I'll give you some hints, right? And I'll give you the symbolic variables that we need to start with. It is a triple integration problem, and please reference the instructions. We'll get to that in a sec though. Okay, so in the last part that we need here, let's go look at the instructions real quick. It says we need P1CTP, determine the tangent plane at 1 and call it, okay, so the tangent plane, we need to remember what that is. Right, so let's write ourselves another line of code. I know this is taking a little bit longer than expected, but this is half your project, to be fair. Right, so our tangent plane, or P1CTP for tangent plane, is the very first thing we need to do is evaluate the function, right? You could think of this as our intercept at the original function, right? So subs f, we need to evaluate x comma y at 1, 1, so similar to what we just did. Right, that takes care of the first part. Then we need to do plus. We have same idea, and really, let's see what can we copy and paste some stuff? Yeah, let's do this. I'm gonna make life easier. So this is plus. I'm gonna copy and paste this just to make life easier. All we need to keep doing is changing f in this case, right? So instead of f, now we want the partial with respect to x. Okay, and we're going to multiply it, x minus 1 plus control V. We'll change this now to P1CY, and same idea, this will now be times y minus 1 because it's the 0.11, right? That's where that minus 1 for x minus 1, y minus 1 is coming from. And we'll control save that. Actually, let's go ahead and just control save. I'll CLC the bottom here. We'll output to the command window. See, this is exactly why we do this. Unrecognized variable, P1CY. Okay, so you guys are lucky because in order to do this, right, P1CY has to be specified, but I mean, there's not a whole lot going on here, so I'll give this to you guys. I don't like the red, and we can run. Boom. Right, and of course you guys are going to have different numbers here, but here's my answer. Semicolon so it doesn't output to the command window, and the last part. And then you guys will be responsible for P1D. Right, the last part is the graph, and we're going to call this figure 1. And in order to do this, we need to use what's called fsurf. And we're going to do fsurf of f. And if we want to graph these two things on the same, we'll say hold on. And I just need to do fsurf of P1CTP. Control save. And we will go, so I'm going to CLC everything out of here. We'll do a run. We should have our first figure. And that'll take us to the end of this part. Hopefully we have our first figure. It's still running. There we go. Awesome. Okay. At the very end, so I'm going to do one more video for part 2. Let's talk about part 3. I won't keep us much longer in this video. What I will say for part 1D, and of course always specify what you're about to start, is that you will need sims of z and r, right, and theta, right? So there's going to be a triple integral, and maybe ask yourself, well, what is this? Z, r, and theta. That means I'm doing a correct cylindrical triple integration problem for 1D. Right, now you can do all the integration in one step. You can break it up. Please go reference, right, the instructions, right? So if you're curious, something different, if we scroll up to the operations, scroll up, limits, integrals, and partial derivatives, all the stuff that we've done, right? This is everything that we've done. Here's fsurf, plots the tangent plane, if we were curious where that's coming from. And finally, right, this is a double integral problem here. This is a double integral problem in polar coordinates, but what are we doing? We're doing cylindrical. So we are doing polar, and we're just adding on the integral of z, right? So we have first, second, and then we have double int. So you can imagine you're going to have first, second, third. You can call this one triple int, and you can do VPA. Now, VPA outputs a decimal approximate answer just in case it's a little bit too crazy with the decimals. Sims r theta. So everything you need, right? Triple integral over the unit sphere. This might even be more specific to what you need here. So again, all of everything that you need in 1D is right here. If you have any questions, feel free to message me. Thank you guys for watching the rest of this video. I will put up part 2 shortly. Please get started on part 1. And at the very end of part 2, I will show all of the functions. So I'll run the entire code. I won't show the whole code, but at least you guys can make sure all of your, or not functions, I'll make sure all of your figures match up, right? So I'll run the entire code. You guys can look at all the figures, and you can kind of specify whether you did it right or not if your figures look like the ones that I have. All right, thanks guys. You have a good rest of your break.